So let's get back to loops. This is where the power of computers doing repetition really sits. So with loops, we have different arrangements of how to repeat a task multiple times. And while we are repeating, there's things that could change dynamically while we are repeating, and the computer will act accordingly, which is really helpful. So one type of loop, let me go back to the more basic loop, which is just a for loop. Okay? So there's multiple ways you can implement something. And the basic for loop has to have a way to count how many times it's doing something. And we typically have some sort of an index doing that job. So if I just had the very simplest task of summing up a bunch of numbers that are in an array, I have to figure out how to count those numbers. So I can decide to basically create a range of my indices, and there is a range function that gives me such a range. So if I had just like a simple vector that I use linspace to define it, so it's just a vector of numbers, then I can actually go and create k, which is my index. I can call it anything I want. I, j, k are the most common ones, but then it can be index, id, you name it. It's up to you. I typically go with some version of ijkl, somewhere in there. And for this k in range between 0 and the length of the array, okay, I can actually go and keep updating this sum of numbers. How I'm going to call this sum doesn't matter, as long as I start it with a 0. So I always need to initialize things. If I'm computing them, I need to start them up with something. And so I initialize sums with zeros, and then in the loop, I keep adding to this number. I could have also do the counting with just saying for x, let's call it xk in this x. So I can just use the array itself to count. That works as well. In that case, I would just do sum up this xk instead of x of k. Okay? And then let's just do quickly, this is the last one we did last time around, is I can also nest loops as many times as I want. It's going to get slower and slower if I go into multi-dimensional arrays. But in this case, I'm using two nested loops to go over the entire two-dimensional array. And this is equivalent of saying, okay, go to the row 1 and then repeat for all of the columns in that row. Then move on to the next row and then repeat a loop for all of the columns in that row. So this second loop, the J loop, executes for every I row. Okay? So I step into the I loop, and then I step into the J loop. But then I keep moving in the I loop, and I repeat J loop again. And I go another I loop, and I repeat J loop. Okay? So this J loop executes for every I. Okay? And that's how I go spatially over this two-dimensional array, if that's how my data is arranged. It's as simple as that. I could do that with 3. With 3, I can visualize. With 4D, I have trouble visualizing four-dimensional array. But I could basically repeat this or nest this loop as many times as I'd like. I decide. Okay? So every time you have a loop or some sort of something that has a block structure here, that block structure can be any type of the code you'd like that is valid otherwise. Okay, so it kind of works recursively. And you can keep repeating things or doing anything you will do in any code you can do here, right? But that block of statements that is indented by 4, okay, executes only during that loop, right? So it doesn't execute otherwise. Okay, so let's now move to another type of loop. Okay? So there's also sometimes that I don't have a clear counting technique, but I have to execute something while an expression is true. Okay? So I have to engineer a way to calculate that expression based on my data, but I can keep seeing whether, so let's say that the rain is falling. I don't know the flux of the rain, how much rain actually falls per minute on a certain area. That changes depending on how badly it rains outside. And I'm not necessarily designing it or in control of that, but I can have a gauge that is checking, well, where is my level of the rain that has fallen until now. So I can basically turn something on or off depending where that level is. So that's something that like I can't count that easily. Okay? I don't have an index that I can keep counting and repeat my loop, but I might want to do something while this gauge is less than a certain level. In that case, I use a while loop. So the syntax for this while loop is while some expression is true, so this is my logical expression, similar to the one that I use for if statements, okay? So something that I can evaluate as true or false, okay? So while this is true, colon is an important part of all of these, anything that has a block structure afterwards. And then I have this block of statements that is indented by 4. This block will execute only if this statement is true. So whatever it is that I put here, design is up to me, executes only if this expression is true. So basically, x is equal to 1. I have to initialize something in the code. And I say, while this x is larger than 0.01, keep dividing it by 2. So it's going to replace the value of x dynamically in this block. So on the first execution of this, my x will be 1 over 2, 0.5, and I'm going to print it. And then while loop will come in again and say, well, is x larger than 0.01? The answer for 0.5 will be yes. So I'm going to go into the blocks of statements, divide that 0.5 by 2, and become 0.25. Then I'm going to print that 0.25. Then I'm going to go to the while loop again, check whether the statement is true. If it is, proceed. For 0.25, I'm going to still be larger than 0.01, and I'm going to keep going until I basically fall under 0.01. Okay? And that happens for the 0.078125. For this number, I get into the while structure, check the expression, okay? And it's going to be false, and I'm just going to stop and leave. Okay? So let's program that. Let's give it a try. So I want to keep dividing number 1 until it's too small. Ba-ba-bum. Okay. Open. Let me find my last lecture, last one. It was 3.1. This one. So this is going to be while loops. So I'm going to initialize my x to 1 and basically divide x by 2 until it is less than 0.01, then stop. So while my expression, the expression that I'm going to keep checking is that x is larger than or equal to 0.01, colon, an important part, and you can see that Python immediately indents by 4. what am I going to execute? I'm going to divide x by 2. So I'm going to replace x by x divided by 2. And that's going to update dynamically my value of x. So I'm going to print it just as a check. Yes? I don't need NumPy here. So I'm going to leave it with that. But good point. As a default, always import NumPy. I'm going to need it probably in my next exercise. I'm going to import it then. So this is indeed what I get, similar to what was shown in slides. So on my first go, I'm going to get 0.5 printed. 0.5 is still larger than 0.01. I'm going to keep going, 0.25, 0.125, and so forth until I fall under. Now, question for you. What happens if I do this? What is the change?
You will print x equals 1, right?
Print the last one.
It's going to print x, whatever it is. But when? What happens if I do this change? If my print is actually indented with while? It won't print every time I execute the loop. So this way, it's within the block. It's going to execute every time the block executes. This way, it's actually part of the code that continues. Let's try. So it does the loop, whatever it does there. It doesn't report anything because I'm not asking it to report anything within the loop. Okay? And then it prints x at the very end when it exits the loop. Okay? I mean, I can, in the block, do whatever makes sense. I can say, howdy. Okay? Okay? It's going to keep printing howdy. Whether that makes sense or not, computer is not questioning. For better or worse. It also is not questioning our logic. What happens if I actually keep dividing by 2? Keep multiplying by 2? It's not an error. It's going to keep going. But there's nothing to stop it. Because x will continuously be larger than 0.01. It might actually overflow the memory. We're going to get to that next time. And whether it actually evaluates that infinity, whatever it stores at infinity, as larger or smaller than 0.01, that's a good question. Or most likely, the answer is no. It's going to keep thinking it's larger, and it's going to keep spinning. Let's keep spinning. Let's actually give it a shot. We're going to have to save your Python notebook right now. Because once you start keep spinning, you might lose some data. Just FYI. Let's see. We might need to either kill the browser, kill Anaconda.
How would we do it if we wanted to say if it was true or false?
Huh?
If we wanted to do this, how would we do it to where it would say if it was true or false?
It would save what?
True or false? If it was greater than or equal to 1.01.
Why would you want to say? You want to save that as a check?
No, I wanted to say if it's true. I wanted the print function to say if it was true or not.
Well, the moment you execute this, that means that it is true. You can also say print. What? Wow.
Oops.
Whatever it is that I had copied in there. Copy. Let's try printing that. That's technically true or false. Let me keep divide. Let me do that check. See? True, 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 true. False. Boom. Yes? Okay. So get it to print true or false. You just print. This is evaluated as a variable, as true or false. It's not stored as a variable, but it has a logical value that is true or false. Logical is a type. Okay, it's a type that can be true or false. Just like integer is a type, or string or text is a type. Okay, so I can print whatever. Let's try that exercise. Everybody wants to. Again, your web browser might lock, okay, and become unresponsive because it's getting the stream of data and has to keep processing it, and it's not stopping. Okay, so there are occasions that this is a good exercise. Computers cannot always guard themselves against bad logic or some event that overtakes the memory. I can also ask it to open. You had a nice homework exercise opening array, right? And opening a file. That file could have been too big for the computer. That will freeze it, okay? Because its memory is used up. Just like when you get too tired, your memory is used up, right? And you can't function properly. Same for computers, okay? Similar physical principles, not the same. Your mechanisms are a little more chemical, whereas the computer mechanisms are a little more electrical. Okay? All right, let's give it a shot. Again, I'm gonna possibly have to, and it's not printing anything. All I can see here is that it's executing. So I'm not printing anything because I'm not asking to, so question is, can I stop it? Let's try stopping it. Okay, I can't stop it. Sometimes, if I'm actually printing things, that might actually cause it to lock down. Let's try. I'm going to try to now. I want to freeze my web browser. So you can see it keeps printing, so it keeps getting data into it, right? And there's nothing to stop it, so it just keeps printing things. Let's try stopping it. Interrupting kernel. It actually worked. Okay? So your options here are to stop execution with the stop. You can just click and turn off this browser. You can kill Anaconda from the outside. You can do this and just, right? So there are some options to actually stop this from going, and hopefully it didn't freeze your computer so you don't have to restart the computer. Okay, this is not terrible. All right? So again, you apply the logic. For and while are tools that you use, and hopefully you use them effectively. Okay. So let's give it a shot with. Again, it's okay if it freezes. Let's pick one of these exercises that will be kind of common for in your homework or exam that is coming up. 1, 2, 3, or 4?
1.
Oh, 1 is the easiest.
That looks familiar.
Let's do a simple one that is a very simple variation of what we just did in class. So I asked for a sum. This weird sigma sign is a sum. The sum 1 through n is simply summing up elements 1 through n of array x. So we're gonna assume this x exists. So you're gonna set yourself an n. It could be 100 elements, and create an array that has at least that many. Create an array that has 200, just to be safe. Okay. And then I want you to add all of the elements squared from that array. Let's get going. So open up another little cell. And if you are done with that, keep going with 2 and 3. I plan to do 1 and 3 today. So first exercise, just create yourself an array that has enough elements, and then you can calculate sum of n of them. And I'm saying write a script, some script.py. If you're working in Python notebook, don't worry about naming it. You can create a separate script, or you can work with whatever notebook you have open. That's irrelevant, just solve it though. How you call it doesn't matter. Whatever it is, something locked up, so it's not even executed. Stop. Or restart. So normally, if it gives a star, that means it's working on it. Now, maybe you think it's just or you can just leave them unexecuted, that's fine. So expect to submit number 3 as a quiz for today, or whatever we call them. They're graded as quizzes, but they're in-class exercises officially on Canvas.
What are they doing again? What did they do?
I typically just let them be due by the next class. That we avoid collision when any other homework or test or whatever it is that is due. All I want you is to complete it. The best use of your time is to complete it right now. But if for some reason, like your web browser not communicating well with you today, you don't manage to complete it in class, then you complete it afterwards.
So you want X to be a predefined N? For 3?
This is just given us, so this is a little bit of freedom to you. You can interpret that N as all of the array members, or you can put in an N as 50 and sum up first 50. Okay. So that's open to interpretation. Yes?
I'm not quite sure. I'm making this array. Add this one by one.
You're not squaring it though. You need to square the element.
I mean, for now, I just want to add them. But,
Oh, if you want to just add it?
but then I don't know why, but big numbers. It's called up by increment. I'm sure it's This one has to count away. This one.
Yeah, it depends on the variable. So this one just.
Okay.
Oh, wow.
Okay.
Anyway. Typos are never really headaches, but.
Just so I know, so I know
I want to jump in so quickly, I want you to work there. At least some portion of it. At least to start thinking as opposed to just like retyping, right?
that's just the random number.
So your, what is your correct name? So just square that A. That's it. Yes, so this works. This is so good. I want you to hear me.
And so this first element is 0, and the second, the
You need
last
to
one is 1. And did you do that as
So, yeah, since you're recording.
So how do you do all the time?
Because I think the last one is this last one.
Well, that one I think.
Column number 2, or your time. And you said some of that is beta. You did say some of it was beta.
Our line is our loop index, so we don't need to change it.
So I can figure out.
It's changed automatically. So we need a sum. Please don't do sum because sum is reserved by
Okay.
my sum or someone.
And for every item, you come
So you add something to my sum, my sum plus something plus something.
plus. Square.
That thing is the sum.
And then add the previous, square,
And then print
some
next to
square
it.
value to it.
Right.
So, alright, maybe I just don't know how to use the PGE space.
Yes, that's,
Plus.
but yes,
Now,
it was
that's
still.
defined really slow. We will give us the right
X
answer.
equals X plus 1. Well, that's just equal.
So if we have X defined for, okay, so now we need to define X.
So you're multiplying.
Well, now we're just trying to get the sum of the products.
Yes, that's the next one, yes. So, but you're not multiplying. So your product at home has to, apple, this actually has to be I times index times index. Yes, because index is I. So you're calling your entire product I, whereas I'm calling I index. Cognitive
Alright.
mismatch there.
Square of 1 is 1 square.
So maybe it's just never starting to be larger than 10.
9 and 5.
starts from x
So final will come from 0. This is the number 0. This is number 0. This is number 1. This is number 2.
is not less than 3, so that's not.
So that's it.
Stop.
Implies being on number 2. Number 2
Or
is the
or like n itself, n is next. Yes, n times,
Because we're
but we also need that.
So this one
is actually one
read
is
word,
by
one
there's an array x, and that's x, this is your x of 0, x of 1.
Oh, really? This is saying.
So, but
Okay,
it's
so
x of 0, 1, 2, 3, 0, 1, 2, 3,
that's just one.
values are
Plus 0 to that. Somewhere in
and I want
one.
to take both
The
inputs
second, what does it mean by array?
and the value
One.
that is
Link, three squared.
so right now, this is your value associated with value.
So that's the new.
But you need an index, no?
And the third time around, x is 2.
And you don't want to start with 0 because you multiply with
That's
0.
it.
Alright, so I would say from n in the range of 1 to
The first one is 1, 10, right? So this is
and then multiply times and times
x
x.
is 0 right now. That's when it starts. And
And
then
that's
at the
precisely
end,
what
x equals 1, so the x
you
keeps
need those
increasing
index
every
in the
time
value.
the sequence is over.
Not
So 0, 1, 2, and then by 3, it doesn't count because that's not determined. So literally 3 times. 0, 1, 2.
It's defined, or like it's not.
Oh, you know what? Because being wild, so.
something with
So.
zero.
Okay.
So sometimes things just get stuck a little bit.
Okay.
Shove something else. So let me comment on this number 3. So first off, here I'm asking to start from 1, right? And technically I know that my indexing is starting from 0. Here really, whether I start from 0 or 1, I skip that first one or not, doesn't really matter that much. In number 3 it matters a lot because I don't want to multiply with a 0. Okay? So here I really, really want to start from 1. Here we can have a philosophical debate whether I meant this to be first member or 0th member. But if I say 1 in the exam, take it as 1. Okay, don't take it as a 0.
So do we take it as 0 now?
Now for exercise, it doesn't matter. I'm just telling you that that's a little bit of a... So in here, it doesn't matter all that much. Not a big deal. Plus minus 1 of those elements. But here it matters because you're going to multiply with 0. And then, well, the result is 0. I don't need to multiply anything. Okay? So let me just do this. So that's one comment. So here I want to comment. So I'm not going to solve. I'm going to solve the one afterwards. But I want to comment on this, that it's important to differentiate I and x of I. Okay? And you can run your loop as either elements of X or indices of X, right? But here I need both, so it's good to have a loop that is for I in range from 1 to length of X. Len of X is length of the vector or the array. So that's the best approach here. And n refers to the number of elements, or maybe n is given ahead of time, so you can give yourself an n and run that loop from 1 to n. Okay? But here I'm saying n is element of X. And then if product is larger than 10,000, you should stop the computation. So there is a break to stop the loop. Okay? So the syntax is simply, if you say if something is less than or larger than 10,000, you say break, and you stop. Okay? So let's do a quick practice on that. Yes?
Sorry. Just that I still get confused for asking that. What does that do, and why would we have to put the 0 times 2?
So it works either way in this first one, whether I start from 0 or start from n, or from 1. But if I start from 1, I'm skipping the 0th element because Python has it.
Yeah, so whenever we start something, we always have to stay first word.
No, whatever I tell you.
Oh, just, okay, I just didn't
But
get why.
in this
why do we
case,
have to
in
do
this
that.
case, it doesn't make a huge difference. Like it's just my whim whether I want to start from 0 or 1. Here it makes a huge difference because I'm multiplying, so I don't want to multiply with 0. That's all.
And to tell him to start there, we just have to add it before.
If I tell you to sum up all of the elements of X without numbering them, then it's all of them and they start from 0. Okay? If I tell you to start from 1 or 2, you start from 1 or 2, or 17, or whatever it is.
Okay. And for I in range, what is that doing?
So range of 100 will by default start from 0, or you tell it range of 0, 100. That's it. So there's two ways to do range. Let's just quickly review that.
Yeah, I'm sorry, I just forgot that was the range.
Yeah. Let's see. So just quick comment on how break works. I need to clear this. There's this kernel restart and clear output will just give you a fresh start, especially when you have something like this. Okay, so I removed this and I'm gonna put division here just in case I execute it again. Okay, so let's do how break works. It literally just does that, it breaks. So I'm gonna do a very simple one since we've been talking about range for I in range of, or X, sure, X, I made a typo, but it works, 0 to 5. If I just printed X, I would of course get 0, 1, 2, 3, and 4. Now I can say, hey, if X is equal to 3, or 2 maybe, break. Okay? So then at 2, it said, okay, break, I'm done with the loop. So break breaks the loop that was just above that. Okay?
How does it know that it needs to space them equally, 0, 1, 2?
Because of this. So look at that. Oh, that's just how print works. At every execution, it's going to print a new variable.
To tell it, space it by one element.
It's no, because I'm executing this one after another, and the way print works is going to use one line to do that, whatever it is that you want to print. Now, what is the difference between this and this? What's going to be the difference? Is it going to print 2 or not? No, because it's gonna break before that. Let's give it a try. Whoops, and I did not, how did I erase colon? Okay. Subtle. In the entire for statement or if statement, it did not much change. What changed is what did I print and when. Okay? So this tells you that immediately from this point, I get out. I simply get out. Whatever is after here doesn't matter. I can say hello world or whatever it is that I want to say afterwards ain't gonna happen. Okay? So basically it breaks immediately at the statement. Nothing in the block of statements continues to gets afterwards, after break, gets executed. Of course, only if it got to break. If I had 20 here, well, I would never get to 20 with this range. So nothing would ever happen, as if I didn't have a break there, because whatever I asked it to break if x is 20, which never happened. But if x is 2, it will happen. Okay? Again, computer is just doing what I'm telling it to do. Whether that makes sense to me or not, that's not computer's concern. Okay. So now I want to just very briefly start introducing functions. Function is nothing really new. Function is now going to allow me to whatever code I learned to write. I want to package that and execute it again, especially if it's lengthier. And I also want to be able to modify. So for instance, calculating this sum of squares of x, or values of x. I want that to execute for every x. And I just go and give it a new x and it executes again. Actually, there is a function like that already. That is actually called, there's actually, how many times did I say actually today? It's like bad language days for me. So let me create, so there's a function already that does that. So if I just do sum of something, so I'm going to define myself an array and I can just say sum of x, and I think I need to print it. Oh, I don't. It's going to spit out the sum. So sum of x actually goes and executes that for loop and creates a sum. I'm just torturing young minds here by showing them how that's done behind the scene. Okay. So now, if I want to package anything, whatever code I create as a function, here's the basic syntax. I'm going to start simple. So defining a function, I can repeatedly execute. Works like follows. You say def, define. And right now, I'm going to just do function without any input. And I'm going to call it hello. So hello is the name of the function. It doesn't have any input, so I just give it empty brackets. And I'm literally going to print hello world. This is a historical sentence, by the way, from one of the first textbooks on C. Ever since, there's hello world as a programming exercise wherever we go. So it was textbook of historical significance. Okay? And then I'm going to say return, go back out of this function. Again, I have this block that executes only within this function. And every time I have a block that is indented, I have to start it with a colon. That's the syntax in Python. So that's my function definition. Nothing happens, I just defined it. And to execute this function, I can say hello. And I don't need to call it with anything because it doesn't have input. And now it executed. So this is just a definition. Nothing happens. It's sitting on standby until I actually call the function. And again, you know functions already. Print, write, open, you name it. There are functions that are just functions that we call with any object. There are functions that are associated with objects, so you can say x.shape, right? Shape is a function that works on x, in which case you don't need to give it an input. It already knows that x is input, okay? So this is just, again, I can package any block of statements in here, and I can also give it some input to work with. And that's what we're gonna start working with on Friday, okay? I see you on Friday. Ningyu will open up in-class exercise, or he already did. He's probably, yes. So please submit that by the next class.
So, I'm sorry, when I printed my homework, it came out like super crappy. Like, it's like, I printed out a couple of times, but every single time it just came out like this.
That's
Is
fine.
that
Just
okay?
negotiate that with the boss up there.
Sorry.
Uh-huh.
I just wanted to